Okay. Okay. So there has been a bit of delay because of technical issues, but again, we're going to start this class now. Good evening, Shakir. You are a regular attendee of this class, and I think you know today's topic,
Yes,
Boussinesq
sir.
theory, right? Okay. So, as per the feedback which you have given last day and some other people have given, the number of numerical has been increased in this module, in this live discussion. But since this chapter, this topic of Boussinesq theory, is a part of stress distribution, which has been already started in the previous live discussion, right? Westergaard's theory has been already discussed in the previous class, right? Along with some numericals. So the number of multiple choice question and true false statement, these have been limited over here. Okay, there are 10 numericals over here. So I believe if I have given you previously 15 minutes to solve around 20 questions, okay, I believe for solving 10 questions you will need 20
Yes,
minutes,
sir.
10 numericals, 2 minutes each. Will it be okay?
Yes, sir.
Will it be
Yes, sir.
okay? Okay, okay. Okay, so like the
Yes, sir.
previous
Right.
classes, there will be some multiple select questions. Okay, someone has joined. There will be some multiple choice questions along with some numericals. I have increased the number of numericals here, so please take out your copy, pen, and scientific calculator. Okay, I'm going to start right now. So first, write down the questions as the previous weeks. You would just write down the question at first, and then I'm going to give you some time. And today I'll give you 20 minutes because there are 10 numericals. After that, I'll start discussing the answers one by one. Okay. Okay.
Yes, sir.
First question. According to Boussinesq theory, the soil mass is, the options are homogeneous and isotropic, homogeneous and anisotropic, heterogeneous and isotropic, heterogeneous and anisotropic. According to Boussinesq theory, the soil mass is homogeneous isotropic, homogeneous anisotropic, heterogeneous isotropic, heterogeneous anisotropic. The question is clearly visible, right? Shakir, Abdul. Okay. If there is any problem, please stop in between. Okay, next question. At constant r, that is r equals to 1 unit, the vertical stress is maximum at z equal to, z is the depth, and this is as per the Boussinesq theory. When we consider r, that is the radial distance, as 1 unit, then at what depth the vertical stress would be maximum? The options are 1.225, 0.1225, 2.124, 1.625. Excuse me. At constant r, that is r equals to 1 unit, the vertical stress is maximum at z equal to 1.225, 0.1225, 2.124, and 1.625. Sorry. Next question. At zero radial distance, the value of Boussinesq influence factor is. At zero radial distance, the value of Boussinesq influence factor is. The options are 0.647, 0.478, 0.888, 0.239. That means at r equal to 0. Okay. At r equal to 0, the value of Boussinesq influence factor is. I repeat, at zero radial distance, the value of Boussinesq influence factor is. The options are 0.647, 0.478, 0.888, 0.239. Next question. The true false statement. Whether it is true or not or false, you have to answer. The Boussinesq influence factor is a function of R, Z, and Q. R is the radial distance, Z is the depth, and Q is the loading intensity. That is the UDL, uniform distributed load, or load per unit area, whatever you call it. The Boussinesq influence factor is a function of R, Z, and Q. True or false? For students who have joined now, this is the fourth question. The Boussinesq influence factor is a function of R, Z, and Q. R is the radial distance, Z is the depth, and Q is the loading intensity. This statement is true or false, it is state. Alright, next question. The change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. I repeat, the change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. Options are increase by 20%, reduction by 40%, increase by 50%, or no change. I repeat, the change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. Your options are increase by 20%, reduction by 40%, increase by 50%, or no change. Next question. Okay, up till slide number 6, there is question number 5. Is your MCQ and true false questions. From slide number 7, there is question number 6. All the questions are numericals. So first, write down the numericals carefully, including the data. Then I will give you the time to solve them. Okay. Okay. Next question. The first numerical. A circular area of 7.5 meter in diameter on the ground surface carries a uniformly distributed load of 3 kilonewton per meter square. Find the intensity of vertical pressure. Okay, just a moment. Okay, for those who have joined right now, I'll just repeat. There are 5 objective questions. I'll just repeat them afterwards. This is the first numerical. Write down the numericals along with the data very carefully. I'll give you time to solve them afterwards. Okay. A circular area of 7.5 meter in diameter on the ground surface carries a uniformly distributed load of 3 kN per meter square. Find the intensity of vertical pressure below the center of the loaded area at a depth of 6 meter below the ground surface. I'll repeat once again. A circular area of 7.5 meter in diameter on the ground surface carries a uniformly distributed load 3 kilonewton per meter square. Find the intensity of vertical pressure below the center of the loaded area at a depth of 6 meter below the ground surface. And all the questions from here till the end you have to solve using the Boussinesq theory, because the chapter is only that the chapter is itself based on Boussinesq theory of stress distribution. So everything, every numerical, where you have to find out the stress, you have to apply the Boussinesq theory. Okay. Okay. Next question. A circular area is loaded with a uniform load intensity of 100 kilonewton per meter square at ground surface. Calculate the vertical pressure at a point P so situated on the vertical line through the center of the loaded area that the area subtends an angle 90 degree at P. I'll repeat the question. A circular area is loaded with a uniform load intensity of 100 kilonewton per meter square at ground surface. Calculate the vertical pressure at a point P so situated on the vertical line through the center of the loaded area that the area subtends an angle 90 degree at P. I hope this question is clear. Is the question clear, everyone?
Yes, sir.
Okay. So there is a circular area where the UDL has been given. That area, it subtends an angle of 90 degree at a certain depth. The point is called P. To find the vertical pressure at that point, and the point is situated vertically below the center of the area. Okay. Next question. A concentrated load of 200 kilonewton acts at the ground surface. Find the intensity of vertical pressure at a depth of 10 meter below the ground surface and situated at the axis of loading. Second part of the same question, what will be the vertical pressure at a depth of 5 meter and a distance of 2 meter from the axis of loading? I had given this sum the previous week to solve using the Westergaard analysis, but now it will solve using the Boussinesq analysis. I'll repeat the question. A concentrated load of 200 kilonewton acts at the ground surface. Find the intensity of vertical pressure at a depth of 10 meter below the ground surface and situated at the axis of loading. What will be the vertical pressure at a depth of 5 meter and a distance of 2 meter from the axis of loading? There are two parts. The first one, the point is situated at the axis of loading, vertically below the center point of the load at a depth of 10 meter. And the second part, the radial distance has been given along with the depth, changed depth has been given. Both the cases to find out the vertical pressure or stress at that particular point of concern. Okay. Next question. A rectangular area of 3 meter by 1 meter is uniformly loaded with load intensity 100 kilonewton per meter square at the ground surface. Calculate the vertical pressure at a point 4 meter below one of its corners. This question, if you don't remember the formula for the rectangular loaded area, okay, there is a particular formula utilizing m and n ratios. M equals to a by z, n equals to b by z, where a and b are the half length and the half width. So if you don't remember the formula, it is better actually to convert the UDL to a point load and then find out using the radial distance formula. Okay, is it clear? Shakir, is it clear?
Yes, sir.
Yeah, it is better if you don't remember the formula, just convert the UDL into a point load and then find out the pressure at the corner using the formula, Boussinesq formula for concentrated load at a radial distance r equals to 4 meter. Not 4 meter, sorry, at the corner z equals to 4 meter and r you will find out using the what to say, geometry of the rectangular area. Okay, so rectangular area of 3 meter by 1 meter is uniformly loaded with the load intensity of 100 kilonewton per meter square at the ground surface. Calculate the vertical pressure at a point 4 meter below one of its corners. Okay, next question. Uniform intensity of loading at the foundation level of a building 10 meter in width and of infinite length is 100 kilonewton per meter square. Calculate the vertical pressure under the center line of the footing at a depth of 10 meter. I'll repeat the question once. Uniform intensity of loading at the foundation level of a building 10 meter in width and of infinite length is 100 kilonewton per meter square. Calculate the vertical pressure under the center line of the footing at a depth of 10 meter. The length of the foundation is considered to be infinite. Find out the vertical pressure at the center line of the footing. Z equals to 10 meter. Okay. Next question. A point load of 100
Sir,
kilonewton.
1 minute last question, sir.
Okay, fine. I'll give you 1
Sir,
minute. Yes. You have any doubt or just want to copy the question?
in the question, sir.
Okay.
None, sir.
Okay. Next question. A point load of 100 kilonewton acts on the ground surface. Find the maximum vertical pressure on a vertical plane at a distance of 2 meter from the loading axis. So there is a point load, intensity of which is 100 kilonewton. Just a moment. Yeah, okay. Find the maximum vertical pressure on a vertical plane at a distance of 2 meter from the loading axis. In this question, you don't know the depth, but it has been said that you need to find out the maximum vertical pressure. Okay, so you have to find out at which depth the pressure will be maximum, and then use that depth to find out the vertical pressure, maximum vertical pressure. Okay. I repeat the question. A point load of 100 kilonewton acts on the ground surface. Find the maximum vertical pressure on a vertical plane at a distance of 2 meter from the axis of loading, from the loading axis. Yeah. Next question. A concentrated load of 50 kilonewton acts vertically at a point on the ground surface. Compute the ratio of vertical stresses at depths of 3 meter and 5 meter vertically below the point of application of load. I'll repeat the question. A concentrated load of 50 kilonewton acts vertically at a point on the ground surface. Compute the ratio of vertical stresses at depths of 3 meter and 5 meter vertically below the point of application of load. Keep in mind, I have asked you to find out the ratio of the vertical stresses at 3 meter and 5 meter depth. Okay, vertically below the point of load application. The magnitude is 50 kilonewton. Okay. Next question. A rectangular area of 2 by 4 meter carries a UDL, that is uniformly distributed load, of 8 ton per meter square on the ground surface. Find the vertical pressure at 5 meter below the center and corner of the loading area. Here also, this is the rectangular area, rectangular UDL. So you first try to convert it into point load and then calculate using the generalized formula for Boussinesq theory of point load at the center line and at a radial distance r you will find out using the geometry of the rectangular area. I'll repeat the question. Rectangular area of 2 by 4 meter carries a UDL of 8 ton per meter square on the ground surface. Find the vertical pressure at 5 meter below the center and corner of the loading area. Next question. Find the intensity of vertical pressure and horizontal shear stress at a point 4 meter directly below a 20 kilonewton point load acting on the horizontal ground surface. Here, very carefully you have to notice that I have asked for vertical pressure and horizontal shear strength at a point 4 meter directly below a 20 kilonewton point load acting on the horizontal ground surface. Next part, what will be the vertical pressure and shear stress, that is the horizontal shear stress, at a point 2 meter horizontally away from the axis of loading but at the same depth of 4 meter. Have you finished writing the question?
No, sir.
Okay. Okay, I'll repeat once. Find the intensity of vertical pressure and horizontal shear stress at a point 4 meter directly below a 20 kilonewton point load acting on the horizontal ground surface. This is the first part. Second part is what will be the vertical pressure and shear stress at a point 2 meter horizontally away from the axis of loading but at the same depth of 4 meter. The depth and the load is same in both the cases. To find out two things in both the there will be four answers in this particular question. In the first part, you will find out the vertical pressure and horizontal shear stress. In the second part, also you will find out the intensity of vertical pressure and the horizontal shear stress. Okay, done right now.
Yes, sir.
Yeah.
Sir, is the radial shear stress, horizontal shear stress both are same?
Yes, radial shear stress, horizontal shear stress both are same because if you consider stress in the ground surface, the radial distance is obviously horizontal and the vertical distance is at a angle of 90 degree to the radial distance. Okay. So what is vertical? Perpendicular is the horizontal and radial distance we calculate from the axis of loading, that is the horizontal distance. It is the same
Right.
thing. Okay. Yeah, both are the same thing. Okay. This is the last question, last numerical. The vertical stress at some depth below the corner of a 1 meter by 1.5 meter rectangular footing due to a certain load intensity is 100 Newton per meter square. What will be the vertical stress in Kn per meter square below the center of a 2 meter by 3 meter rectangular footing at the same depth and same loading intensity? I believe those who have solved gate questions, they will be able to solve it. At least they will have an idea. They have solved the previous year's gate question. Have any one of you solved the previous year's gate questions?
Sir, it is simple example.
Yes, hello?
Yeah, it is a simple example, sir. Previous gate model it is.
Yes. If you have solved the previous gate example, you can solve this easily.
Yes, sir.
So, it is 1 meter by 1.5 meter rectangular footing. Okay. So, only one person have said that they have solved. The other two have not solved. Okay, we will discuss, no issues. So, the load intensity is given, but then to find out the vertical stress below the center of a 2 meter by 3 meter rectangular footing at the same depth and the same loading intensity. Okay. So, if you have finished writing the question, how much time do you need to solve all the questions? I believe 20 minutes is enough. Anyone? Have you finished writing this question, Shakir? Or should I wait here?
Shortcut I have taken, sir.
Hello? Yes?
Yes, sir. Copied, sir. Indirect.
No, okay. But the others. Shakir, have you written on the question? And who is this Amrita?
Not, no, sir.
Yeah,
Yes, sir.
write it. You finish it and then tell me. I believe one of you has missed the first questions objectives, right? I think Amrita, right?
Yes, sir.
Okay.
I just wrote half of the question.
You wrote from the numericals, right?
Yes, sir.
You have 10 numericals with you?
Yes, sir.
Okay. So Shakir, first tell me if you have finished. I'll just go through the MCQs once.
Done, sir.
Okay. So all of you have the 10 numericals, only the MCQs. The first MCQ was, according to Boussinesq theory, the soil mass is homogeneous and isotropic, homogeneous and anisotropic, heterogeneous and isotropic, heterogeneous and anisotropic. What is the assumption taken while formulating stress using the Boussinesq theory? The soil mass is homogeneous and isotropic, homogeneous anisotropic, heterogeneous isotropic, heterogeneous anisotropic. Next question is, at constant r, that is r equals to 1 unit, when we take, the vertical stress is maximum at z equals to, what is z? It is the depth. So if r equals to 1, the stress is maximum at z equal to how much? The options are 1.225, 0.1225, 2.124, 1.625. If r we take as 1 unit, then the stress will be maximum at z equals to how much? Next question. At 0 radial distance, the value of Boussinesq influence factor is 0.647, 0.478, 0.888, 0.239. At 0 radial distance, the value of Boussinesq influence factor is 0.647, 0.748, 0.888, 0.239. Next question is, the Boussinesq influence factor is the function of r, that is the radial distance, z, that is the depth, and q, that is the loading intensity. True or false? Whether the Boussinesq influence factor is a function of the radial distance, the depth, and the loading intensity. True or false? Next question. The change in vertical stress in a soil mass estimated by Boussinesq equation when Poisson's ratio of the soil reduces by 20% will be. When the Poisson's ratio is reduced by 20%, what is the change in the vertical stress estimated by the Boussinesq equation? The options are increase by 20%, reduction by 40%, increase by 50%, or no change. Is it okay, Amrita? Now you have all the questions? Okay. So I'll be giving you how much? It's almost 50. We will start at 6:10. Is it okay for you? Everyone? 20 minutes is okay for you?
Yeah, we'll try, sir.
Yeah, okay. So we'll start at 6:10.
Yes,
You
sir, we'll
solve all
try.
the questions and then we'll discuss the answers, okay? Okay, do it. Have you finished solving the questions? Hello?
Sir, I have done everything except one question.
Okay, that question you can solve or you cannot solve.
I could not understood, sir, that 90 degrees angle below the circular.
Okay, fine. Okay. And Amruta Dash, have you finished solving the questions?
Yes, sir. Some of the questions are there, but I think when you will discuss, then only I'll.
Okay, fine, fine. Then I'll start discussing the questions now. Okay.
Yes,
Yes.
sir.
Okay. Okay. So, what is the answer of the first question? The assumption for Boussinesq theory?
Option A.
Option A, homogeneous and isotropic. Yeah, option A, homogeneous and isotropic. What is the meaning of homogeneous and what is the meaning of isotropic? I believe homogeneous you know, isotropic means properties is same in all directions, right?
Yes, sir.
Same properties in all directions, that is isotropic. And if it is not, then it is anisotropic. Okay, next question. R equals to 1 unit. Vertical stress maximum at Z equal to how much?
Option A, sir.
Yes, option A, 1.225. And the maximum value of stress is 0.0888 times Q, the point load. So, if R equals to 1, we get sigma max at Z equals to 1.225. If R is in meter, Z will be also in meter. Okay, next question. At 0 radial distance, the value of Boussinesq influence factor Kb is equals to how much?
Option B, sir.
Yes, how do you solve it?
3 by 2 pi, sir.
Yes, Kb actually equals to 3 by 2 pi, then Z square, right?
1
Sorry,
by
3
1
by 3 by CQ by 2 pi Z square, yes. 1 by 1
1 plus R by Z
plus R by Z
square whole square
whole square whole to the power how much?
5 by 2.
5 by 2. So R equal to 0, R equal to 0, this becomes 1, 3 by 2 pi. Yes. Next question. True or false?
False.
Yes. Why? It is a function of
Only R by Z.
only R and Z. So if you want to explain this mathematically, then I will write KB equals to a function of R, comma Z. Okay, here, right? Okay. Next question. Change in vertical stress when Poisson's ratio reduced by 20% is how much?
Option D, sir.
Option D. Why?
It is independent of Poisson's ratio.
Yes. So which thing is dependent on Poisson's ratio in stress distribution chapter?
Westergaard's, I hope so.
Westergaard. There is a particular factor called eta, right?
Yes, sir.
That is dependent. That eta is a part of Westergaard's influence factor, right? That eta is dependent on the Poisson's ratio. But in Boussinesq analysis, it is not dependent on the Poisson's ratio. So what does this statement mean? If you have a particular problem, we are solving using Boussinesq equation, and same problem we are solving using the Westergaard's equation. What is the difference? What will be the difference in the approach in both the cases? Yes. You have one particular sum. I asked you to solve that particular sum using the Boussinesq approach and using the Westergaard approach. So what will be the difference in both the approaches?
Where, sir? Under the load or which point?
Any point. Suppose I have given you a concentrated load and I asked you to find out the stress below 6 meter at the axis of loading using Boussinesq and using Westergaard. The basic
Boussinesq gives a higher value than the.
not the I'm not asking about the higher or lower value. I'm asking about the approach. If you say that Westergaard analysis is using the Poisson's ratio, okay, Poisson's
Okay.
ratio of what? Of the soil, right?
Yes.
And
Yes, sir.
Boussinesq analysis, it is not using the Poisson's ratio. So this is the property of soil. So if you want to find out the stress in a particular soil, if you use the Boussinesq analysis, we are not concerned about the soil property because the Poisson's ratio is the strength property of the soil, right?
Yes, sir.
It will vary from soil to soil. So we are not concerned about the soil property in case of the Boussinesq analysis. But in case of the Westergaard analysis, even though we say that most of the soil will have a Poisson's ratio equal to 0, because for elastic materials it ranges from 0 to 0.5. When we are introducing this factor Poisson's ratio, we mean to say that this analysis is dependent on the property of the soil or the strength property of the soil. Okay.
Yes.
So in this approach, the strength property of the soil is not concerned, and in this approach it is being concerned because the other factors, load, pi, z, radial distance, it is same in both the cases, right? We don't use any other extra factors, right? Only eta we use extra in the Westergaard analysis, isn't it? Hello?
Yes, sir. Clear, sir.
Yes, only eta is the external factor which we use in the Westergaard analysis. So in this case, we do not consider the soil factors. Okay. Next question. The first numerical. What is the answer you have got?
1.17, sir.
Yes, 1.17. And how do you solve this? If you see, sigma z will be equal to, what is the formula?
I use the shortcut formula, sir. Q into 1 minus cos cube theta.
Yes, that also you can use. But since this is the first sum, I am just showing you the generalized formula. 1 minus 1 divided by 1 plus a by z whole square. Whole to the power how much? 3 by 2, right? Whole to the power
Yes,
3 by
sir.
2, right? Yes, this is whole
Yes,
to the
sir.
power 3 by 2. Now, when you are saying that theta, then we can say, okay, I'll show that in the next sum. So if we use this formula, what is the value of q? Q is 3, isn't it? What is the
Yes, sir.
value of a? is 7.5 is the diameter, then the radius will be 3.75. Okay, and Z is 6. You put everything in the formula, you'll be getting sigma Z equals to 1.17, right? 1.17 kilonewton per meter square. Your method which you have done is also correct, it is also good. I will be discussing that in the next part and coming back to this part. Okay, so who was left? Amruta, is it clear, this numerical?
Yes, sir. Yes, sir.
Yeah, so Q, A and Z, you just put the values in the formula. The only thing, hectic thing is to remember the formula, but I believe once you revise it will be okay. Next question. This one you can understand, right?
Yes, sir.
So if you could solve the previous question, why can't you understand this question?
Last line I could not understood, sir.
Okay, circular area loaded with Amruta, could you solve this question?
No, sir.
Okay. Circular area loaded with a uniform intensity. If you see from the side, a circular area will be like this. Okay, intensity of 100. Loading intensity of how much? 100. At a round surface. Vertical pressure at a point P. This is the point P. Suppose. On the vertical line to the center of the loading. Vertical line to the center of the loading. So this is half and this is half. Okay. So that the loaded area, this is the loaded area. It subtends an angle of 90 at P. This and this angle is 90 degree.
Okay, sir. That I could not understand.
Yeah, yes. So this is how much? 45 degree. This is equal to theta. And as per your formula, which you have solved in the last question, sigma z equals to q into 1 minus cos cube theta, right?
Yes, sir.
Q into 1 minus cos cube theta. So if this is A, this half A, and this is Z, okay, A by Z is how much? Tan theta, right?
Yes, sir.
A by Z is tan theta. So if you put tan theta over here, you get the same formula. Okay. So if you can find out the angle, it will be the best for you because you can solve it using the short formula. Anyway, so this is the formula you can use for solving this question because Z is not given and A is also not given. You can only find out theta. So what is the answer you've got? Find out.
64.64.
Yes, very good. The answer is 64.64 and the unit is kilonewton per meter square, right? Don't forget the unit. Is it okay?
Yes, sir.
Yeah. Amruta, clear?
Yes, sir.
Yeah. Just a moment. Okay. So this is how you solve
Since
this
angle
problem.
is given, theta is not required here. Z is not required.
That is not required.
Yes, sir. That's the specialty of this example.
Yeah. If angle is given, why do you require Z? Just put over
Yes,
here.
sir.
Okay.
Yes, sir.
This question, concentrated load. What is the answer you have got?
0.955, sir.
Yes. Okay, this is the first part. And the second part?
2.635. Is it correct, sir?
Yeah, 2.64. Okay. So concentrated load is given. Intensity of vertical pressure at a depth of 10 meter below the ground surface at the axis of loading. Right. So what is the formula? Boussinesq formula for concentrated load 3q by 2 pi z square, isn't it? 1 divided by 1 plus r by z whole square whole to the power 5 by 2.
2.
Okay, so Q is 200 kilonewton, Z is 10 meter. For the first question, it is said situated at the axis of loading. For the first question, R will be equal to 0
0.
and Z will be equals to how much? 10,
10 minutes.
10 meter. You solve it, you get the answer as you said 0.9955. 0.955 kilonewton per meter square. Okay. Now in the second question, you have to use the same formula. In the second part, you use the same formula. The only difference is what? R is equals to how much? R is equals to how much?
2 meters.
Yes, R is equals to 2 meter, and then Z equals
5
to how
meters.
much? Z equals to 5 meters. You put it again in this formula, okay, and you get the value of sigma Z equals to 2.64 kilonewton per meter square. The easier thing is if you see any sum where there is a concentrated load and situated at the axis of loading, then you just omit this part and write 3q by 2 pi z square. Okay, or 3 by 2 pi into q by z square. 3 by 2 pi is the Boussinesq influence factor at the axis of loading, isn't it? 3 by 2 pi 0.478. 3 divided by
0.4775.
yes 2 yes 14775 1478. Clear, right? This sum is clear.
Yes, sir.
Yeah. So now Shaki hasn't joined. Okay, Shaki hasn't joined. A rectangular area of 3 by 1 meter is uniformly loaded with load intensity 100 kN per meter square at the ground surface. Calculate the vertical pressure at a point 4 meter below one of its corners. What is the answer you have got?
So I got 6.85 by
6.85
85. Yes, sir.
by converting the UDL to concentrated load, right?
Yes, sir.
Yes. So, okay, we'll try to solve by that. So, if UDL is this one, what is the concentrated load? It will be into the entire area. 100 into 3 into 1, right?
Yes,
It is
sir.
300.
75 is Q.
Calculate the vertical pressure at a point 4 meter below one of its corners. Okay, so this is 3, this is 1, this is the point load. No, why you are telling Q 75? Okay, you
By
can take Q is 75, but if I take like this is the point load and this is the radial distance, then no, you cannot take because it is not said over here that this load is being equally distributed. Okay, so if this is the if you see it in this perspective, side view, this is the top view, this is the side view, then this is the load. Okay, if this entire area is divided into this load, you take this one as the point load, that is Q. Okay, and you are asked to find out at this point, right? If this is 4 meter, this is the corner at this point, right? P. So use the radial distance, no? R.
But normally in the examination they will mention, sir, how many point load you have to consider.
See, when you
Single
are
equivalent.
no, when you are doing sums where you are converting this load intensity. See, for a rectangular area with UDL, we have a formula. Okay, there is a big formula using M and N, where M equals to
Yes, sir, I know. Big
M
formula is
equals
this.
to M equals to A by B, A by Z, N equals to A by Z. So when you are not using that formula and converting this load into UDL, you're already creating an assumption. Okay, you're already creating one assumption. You're already following one assumption, and in general cases, when you consider the UDL, then when you consider when you convert the UDL to point load, it is always proper to say that this pointer is acting at the center of the UDL. This is the entire area. This is the entire area. The concentrated load will be acting at the central point. Now, when you say that this load is acting at the center point, okay, then you can't say that you have to divide this area into four equal parts. No, we have a centrally applied load. Okay, and if you want to find out the load at the corners, you apply the R rule. That is R equals to how much? If it is 3 into 1, this is equals to 1.5, isn't it? This is equal to 0.5. So R will be equal to how much? R will be equal to root over of 0.5 whole square plus 1.5 whole square, isn't it? Are you getting it, Abdul?
Yes, sir.
Yes. So what is the value of R? Find out.
1.58 meters.
1.58. Okay. Now what is the value of Z? Z is equals to 4 meter. So Z equals to 4 meter, Q equals to 300 kilonewton, R equals to 1.58. Put these values in the Boussinesq equation for concentrated load and find out the find out the stress at the corner point. What is the value? What is the answer? You'll get something around your previous answer only, I believe.
6.22.
6 point?
22, sir.
Yes. 6.22 or 6.22. Okay. 6.22 kilonewton per meter square. Okay. I think if you use the actual formula of rectangular load, you will get something around 6. Okay. You are following one assumption and converting this into the concentrated load, you are getting 6.22. And in the previous case, in your case, the method you have followed, you have divided the entire thing into 4 equal parts, right? That is one step ahead of this assumption. So you're getting 6. How much you got? 84, right?
6.85.
Yeah, 6.85. So the more assumption you take, the more you deviate from the actual answer. Okay.
Okay.
6.22 is okay. If the value of some answer is 6 and you're getting something around more than 6.5, then that might be problematic in solving MCQs or something like that. So this is clear, right? How we are solving it? You first convert it into a equivalent point load. Then, if you're supposed to find out the stress in the corner, take the corner length as R. Use R equals to this one, L square by L square plus B square root over Z. You know it is given over here. Find out the value of sigma Z using the formula of Boussinesq theory of point load. Okay, at a radial distance of 1.58. All right. So this one is over. Next question. Yeah. Uniform intensity of loading at a foundation level of a building 10 meter in width and of infinite length is 100 kN per meter square. Calculate the vertical pressure under the center line of the footing at a depth of 10 meter. Have you solved this?
Yes, sir.
What is the answer?
54.98 kilopascal.
54.94 something I've got. Yes. Okay. So how do you solve it? Amruta, can you get the solutions? Is it okay up till now? Or is there any doubt? Okay, Abdul.
Sir.
Yes. So footing at infinite length. So this is the cross section. This is the loading intensity. We have how much? Q. Q is equal to 100. So here 10 meter in width, vertical pressure depth of 10 meter under the center line. This this is 10 meter. The point P. Okay, this is the center line. So what is this is the value of theta which we will be using in the formula. And what is the formula? What is the
Q by
formula?
pi, Q by pi in bracket 2 alpha plus sine 2 alpha. I have used it.
2 alpha by sine 2 alpha.
2 alpha plus sine 2 alpha.
Yes, and I am using theta over here. This is the entire angle. Theta equals to 2 alpha. Then I'll say theta plus sine theta. Same thing. Theta equals to 2
Yes.
alpha over here. Okay. So what is the value of theta or 2 alpha you have got? If this is 10 meter in width and this is also 10 meter. What is the value of theta or 2 alpha you have got? Yes. 53 point something, right?
53.13.
Yes. The angle is 53.13 in degrees. In degrees, right? You have to convert it into radian
Yes.
because you have only theta over here. So into pi by 180 equal to how much? What is theta in radian? The value of theta in radians. Hello.
0.927, sir.
Yeah, what took you so long? You have solved the answer, right? Solved the question, right?
Yes, sir.
It is 0.927.
27.
Good. So in this sine theta, you put theta equal to 53.13. This theta is this one, 0.927, and Q is given 100 by pi. What is the answer?
54.8.
94, right?
Yes, sir.
54.98. Okay. Just a minute. Sine 53.13 plus 0.927 100 divided by 54.972. 927 or 972? How much are
I
you
got
getting? 54.97.
98. Okay, sir. No problem.
4.9798. Yes, okay. 54 point. Actually, in competitive exams, there is a range given. 54.95 to 54, 55. It is acceptable because they also know that silly mistakes can be considered sometimes. So this is 54.97 kilonewton per meter square. Excuse me for the handwriting. It's clear, right? How do you
Yes, sir.
solve it? Yes. So yes, you can take theta or 2 alpha or alpha, whatever you want to in this case. Okay, this question is done. Next question is yes, a point load of 100 kilonewton as on the ground surface and the maximum vertical pressure on a vertical plane at a distance of 2 meter. Yes, what is the answer?
2.2027.
Value of first, tell me the value of z. What is the value of z at which we will get the maximum value of stress?
2.447, sir.
2.47. How do you get 2.47?
R by Z is 0.817.
R by z is 0.817
817.
for the maximum case, right?
Yes, sir.
Yes. Yes. So, what is the value of z?
2.447, sir.
2.447. Yes, but try to remember one thing. This R by z is 0.817. That has been rounded up. Okay. You have seen in the previous question, I have told you I have given this question on purpose because it has a link with this question. Isn't it?
Yes, sir.
Yes. So when r equals to 1, z equals to 1.225. So when r equals to 2, z equals to 2.45. 1.225 into 2. I'm getting 2.45. Yes. So r equals to 1, z equals to 1.225 for maximum loading, maximum stress. Right. So even if you use this thing, you get r by z 1 divided by 1.225. How much you get? 0.8163. Okay, you get r by z equal to 0.8163. So when you are saying you are using 0.817, that means that there has been something rounded off to 0.817. Okay, then you can get a decimal place of error.
Okay, sir.
Because I believe you know the table, right? You have the table with you. If you have the book of BC Purnia, do you have the book of BC Purnia?
Yes, sir, but not with me right now.
Okay,
I have.
so you just check it in the variation of sigma z with z at constant r. Okay, the value of z is given in the first column. That is
Okay,
the
sir.
primary. That is the primary thing. After using the value of z, we are getting the value of r by z. Then you are getting the value of kb, then kb by z square. Then you are getting sigma z. So the primary value is z. So when we take the primary value, there is less chance of the error accumulation, isn't
Okay.
it?
Okay, sir.
Isn't it? So when r equals to 2, we are saying over here, obviously if r equals to 1, z equals to this. If r equals to 1 meter, z equals to this meter. And when r equals to 2 meter, what is the value of z? Z will be equal to 2.45 meter, isn't it? So this is the value of z which you have to use for solving this question. And next thing, it is very simple. 3q by 2 pi z square 1 by 1 plus r by z whole square whole to the power 5 by 2. You have to use the value of z equals to 2.45 and r equals to 2 meter and q as 100 kn. Okay. What is the value of sigma z you find after using z equals to 2.45? Find out. Is it clear, Abdul?
Yes, sir. Yes, sir.
Yeah. Okay.
Not much difference, sir. Only 2.19.
Yeah. Not much difference. Not much difference. But
And also, sir,
yes.
here
Yes.
on any plane other
Yes.
than the under load,
Yes.
and any plane at maximum stress, KB is going to be 0.132. It is a constant, sir.
0.132.
132.
See, you are taking the value of kb on any stress. Okay. You are saying on any stress, kb will be equals to this much. But can you use the value of kb over here directly?
Yes, sir, because R by Z is a constant. Now, wherever you take on any plane, R by Z is a maximum.
Yes.
There only will get a maximum stress.
So if you take kb equals to how much you are saying?
0.132.
0. I'll just take 0.132 into q by z square, right? What?
Yes, sir.
What is the value of q? Q is equals to
100.
and divided by z square.
Yes, sir.
What is z square there? If you have to find out z, na? That is the thing.
Yeah, Z again we are finding that
Divided
from
by
R
2.45 whole square.
whole square.
2.199. Yes, you can do that. You can do that. But
Yes, sir.
the value of kb, you have a formula for kb, right? Just remember, you have a formula for kb.
Yes, sir.
But
Yes,
for
sir.
z, you don't have any formula.
Yes, sir.
This
No.
has been calculated using trial and error testing and all those things.
Yes, sir.
So r and z, these are the primary values. If you use r by z, this is the formula to calculate the ratio. There might be some accumulation of errors if you have any error in z. kb, you have the big formula. If you have z, if you have any error in z and r, the error might get magnified. Okay,
Sure, sir.
so it is always better to use the primary formula. Obviously, if in gate examination or any other examination you have only this question and it is the fill in the blanks, they will give, suppose it is 2.22 I am getting, they will give 2.18 till 2.24 like this.
Hmm.
Okay, but
That's
suppose
the right.
suppose you have MCQ and you have got options like 2.18, 2.22, 2.25, 2.24 like this. They
Yes.
give options like this. Then you have to go for the exact answer. And to go for the exact answer, you need to minimize your error. And how to minimize your error? Take as many primary variable in the formula as possible.
Okay, sir.
Okay, so once you
Right.
take z equals to 2.45 meter, because primary variable changing from this to the double of itself, the value of sigma z will be 2.22, right? I believe
Yes, sir.
2.22. Yes, so 2.22 kilonewton per meter square. I believe this kind of question will be having fill in the blanks sort of question. Then you are free to use your own formulas. Okay, no one will tell you anything to do. But if you have MCQs, then go for the precise method. Clear?
Yeah.
Good. Yeah. Next question. Yeah. What is the answer of this question?
2.77.
2.77, 2.78. The ratio is 25 by 9, isn't it?
Yes, sir.
Why? Because in this question you don't need this load because
It
sigma
is
is,
independent of the load. Cancel.
yes, 1 by z square. So I have to find out sigma 1 by sigma 2, that will be equal to z2 by z1, and this will be whole square. Z2 is 5, z1 is 3, so it will be equals to 25 by 9, or it will be equals to 0.278. Okay, since you have solved I believe you have solved the gate questions, right? Previous year's gate questions. This
Yes, sir.
this kind of question will be easy for you, but for those who haven't solved, they might go for the actual method, like putting the formula, finding out the stress, and then finding out the ratio. That
Yes.
will take some time. Yes, good.
Answer is 2.77, sir. Why you have written 0?
2.77, 2.77, 2.78. Because if you take 25 by 9, 25 divided
You
by
have written
9.
0 point something, sir. 25 by 9 now.
Oh, sorry. 0 point. Yeah. Okay. Yeah, it is 2.77.
Yes.
2.7778 to 2.78. Yeah. Yes, 2.78.
Okay.
Obviously, because 25 is more, by 9 is more than 1, so it is
Yes, sir.
2.78. Yes. Okay. This one. What is the answer? The same way. Okay, have you solved this question again by the corner loading by taking uh, 2 ton per meter square on the, what to say, in the corner? Have you
No,
solved
sir.
this?
Corner I have not done. By I have forgotten. Actually, center I have done it, sir.
How center you have done? What is the answer? Center load
4.328 tons per square meter.
4.328. Wait, this is the area, right? This is 2, this is 4, and UDL of 8. So the total load is how much?
Again,
8
I
into
have
8?
taken 4 point load, sir.
Okay, no. Don't take that like that. Okay, see, this is 8 ton into 8, it is 64. 64 tons. This is the
Yes, sir.
point
64
load,
by 8
cube.
square. Hmm.
Yes. So at the center, you take this load as Q and 5 meter. This is 5 meter. Z equals to 5 meter. So sigma Z equals to,
It is 1.22, sir.
yes, sigma Z equals to 3Q divided by 2 pi Z square. It is 1.22. Yes, 1.22 ton per meter square. find out one of the corner. No, this is the
Yes.
center point. This is 1 and this is 2. What is the radial distance then? I think it is radial distance r equals to root 5. Root over 5. Then CQ by 2 pi z square. 1 by 1 plus r by z whole square. For 5 by 2 at the corner. Because how much? Tell me.
Is it 1.08, sir?
No, no. Wait.
No.
See,
Small mistake.
the previous one you have found out, right? R is equal
Yes.
to root 5. So I believe root 5 divided by 5 is 1 by root 5. Root 5 divided by 5 is whole square. We get it. We add 1. Then we 1 divided by the answer whole to the power 2.5. Get multiply that with 1.2. I believe it is 0.77. See.
Okay, sir. I will do it, sir. Okay, no problem.
See, you need to solve the first part. You already have the first part, right? CQ by 2 pi z square. You only need to do the second part, isn't it? Because
Yes.
CQ by 2 pi z square, z is same,
Hmm.
right? Z is same.
Only
Pi
name
by
is
2.
different.
Yes. So if you do the second part, you get something and you multiply. I believe you will get 0.77. 0.77. Okay. Done per meter square. So again, just to remind you, when you are solving these rectangular area type of questions, you just convert the UDL into a point load and make it applied on the center of the loading area. So if you are told to find out the load at the central point at the axis of loading, use this formula. Obviously, you know that. And if you are asked to find out at the corner of the loading, then use R equals to root over of half of A square plus half of B square. Okay, you find out the radial distance from the center and then apply the entire formula to find out the value of stress at the corner. Clear?
Yes, sir.
Yes, good. Okay. Now, have you done this question?
Sigma Z is 0.5968.
5968. Okay, I will say sigma z for the first part, right?
Yes,
Actually, there
sir.
are two parts. For the first part, sigma z equals to 0.597.
968.
Yeah, 597. I'll say up to three decimal places. 5968, 597, same thing. And what is tau? Yes. What is tau?
0, sir.
What is the formula of tau?
Sigma Z.
Hello.
Sigma Z.
I can't hear you. Sigma z into r by z, right?
Yes, sir.
Yes. Your mic was not working. Sigma z into r
Into R by Z.
r by z. For the first part, directly below the load. So r equal to
R is-
0. So
Yes,
tau
sir.
z equals to 0. Isn't it?
Yes, sir.
Yes. Now we go to the second part. What is the answer you have got for the second part?
0.342
0.342 kilonewton per meter square. And tau?
0.171.
Yes, that into r. What is the value of r? 2 and z is 4. That is this half of this.
Yes,
Isn't
sir.
it?
Half of that.
Half of this. That is 0.171 kilonewton per meter square. Clear?
Yes, sir.
Okay, good. So the last question. Now you tell me, how will you solve this question?
Is a 4 times of KB is the same. No?
Yes.
Is a 4 times of the 100.
First of all, we have taken 1 meter by 1.5 meter like this. This is 1 by 1.5. And I'm saying that at the
Hmm.
corner is 100. Okay. At a corner of the loading is 100. Now double it and double this. So if you divide this into 4 parts, this each block is the same as the previous block, right? This
Yes,
is
sir.
1, this is 1.5. So if this particular block with the same intensity has at the corner 100, then there are 3 more like that. So each one will be adding to this center as their own corners. So it will be sigma z will be equals to how much? 4 into 100.
100.
That is equals to 400 kilonewton per meter square at the center of the load. Okay, each individual corners is adding on to the center of the load, and the load is getting multiplied 4 times. Simple thing. Okay, this is a previous year's gate question.
Yes. Sir.
Okay, since you have solved this question already, it is, I believe, it is of not no importance, less importance to you. But those who hadn't solved this question, they could have benefited. It's okay. All right. Okay. So, is there any doubt? I believe you are the only student over here. Is there any doubt? Any question you want to ask?
No, sir. Think everything is clear.
Everything is clear. Could you learn something new from here?
Sir?
Hello?
Sir, tell.
Hello? Yes, could you learn something new from here?
Yes, sir.
Yes.
Western Ghats theory.
Yes, what? Please be slow.
And Western Ghats.
Western Ghats theory, yes. The difference.
Also that 90 degrees making.
90-degree angle of making. Yes. Okay. So are you regular in the class? I don't see you regularly in this.
Sir, actually, last year I was a topper.
Okay.
In IIT Bombay. I got 99.
Okay. You are doing BTech from IIT Bombay?
No, sir. I got in the last time IIT Bombay NPTEL exam 99 marks.
NPTEL exam. Okay.
And I was the topper in the last time.
Okay.
So this time, due to personal reasons, my mother is expired, so I could not
Okay.
concentrate.
Very sorry to hear that.
Yes, sorry, sir. Yeah, it was recently happened. That's why I could not attend.
Okay.
Even I missed to pay the exam fees. I want to ask you about that.
Okay.
Will
NPTEL
they-
exam fees.
Yes, sir.
Okay. Just a minute. I'll just stop.
The deadline is over, sir. Already on 16th. They
See,
gave a
NPTEL,
reminder. So many reminders.
you can ask the NPTEL coordinator from whom you get the mail, right? You get some mails.
Yes, sir. I gave the mail for them, but they couldn't respond till now.
Okay, you drop them mails, you ask them if there is a helpline number, you also try to contact them, because my only duty is to uh, take this practice class so that you can solve your assignments better and you can
Yes, sir.
perform in the NPTEL examinations better. Apart from that, we are not allowed to discuss anything else in this class, in these sessions, apart from the regular curriculum. So, if you could not get any reply from mail, via mail, you can
Yes.
call them if they have any helpline number. Okay, you can call them.
Okay.
Okay.
Okay, sir.
Apart from that, try to be regular in this session, because I'll be solving more and more number
Sure,
of
sir.
numericals. And one thing I'll ask you, I believe in the next class we have Newmark's influence chart and
Yes, sir.
contact pressures, but that is a very small part of the entire space analysis, isn't it? Because
Yes, sir.
major part. So, is there any other chapters? If you are present in the class, you can suggest me. Is there any other chapter numericals you want to incorporate along with those things?
You can add from the previous 8 assignments 1 or 2 questions, sir, so that it will
Previous
cover.
assignments. Okay. Previous assignments I can add. Okay. I'll see then, because today I have added all the numericals which I could of the Boussinesq theory. I'll see
Yes.
if there are any more numerical related to this Boussinesq theory also. I'll add it in the next class because Boussinesq theory I've covered, Westergaard's theory I've covered. Okay. If I
Yes.
feel like any other previous assignment questions I need to solve, any other different type of question I can solve, I'll add them. Okay. Because
Yes.
only numeric start and contact pressure will not take 2 hours time.
Yes, sir. It's small example.
It is a very small part of the chapter. Okay.
Sir, if you find somewhere in any textbook regarding negative loading,
Negative loading.
you can try, sir. If there is any negative loading question or excavation related question, you can bring it, sir.
Excavation related question I had solved this in the effective stress chapter. Were you present in that chapter, in that
Uh,
live discussion?
no, sir. Most of the classes I missed this time.
Okay, the part where I discussed about the seepage analysis.
Okay, I
Okay,
will go
it's
through, sir. Recorded
okay.
videos. I will go through.
The recorded videos are there. You can just go through, and
Yes,
if
sir.
you have any problem regarding any previous like questions and all, you can ask. Okay, like you
Definitely,
have
sir.
the
Thank you.
material also. There is a
Yes, sir.
Google Drive folder has been shared with you. Okay,
Okay,
if
sir.
you have any problem regarding the materials of the previous classes, you can ask me directly. Okay.
Okay, sir. Okay, sir.
Okay. Thank you so much for attending the
Yes.
class.
Thank you, sir. Thank you very
Yeah.
much.
Yeah. Good evening. Bye.
Bye, sir. Thank
Yeah.
you.